Okay, good evening everybody. My name is Olivier Klein. I'm one of the solutions architect of Amazon Web Services. Thank you for coming everybody. It's a lot of people. My Chinese unfortunately is not very good, so I need to speak in English. I hope that's okay, but don't be shy if there are questions or anything. I want this to be very informal, so if you got a question, just let me know. We even got a whiteboard behind here, so we can talk through solutions. I really want this to be interactive. So today's topic is to look at how we can use some of the open source tools together with AWS to do some data analytics and to do that actually in real time. So for some of you, you might be very new to Amazon Web Services, so I'm going to give a little bit of an overview of what that is, how you can use it, how it works. We're also going to have a live demo later, where we're going to try to look at a live Twitter stream and we start to visualize that. And I'm also going to give some information around URLs and code samples for you to look at. But like I said, if anything is unclear, just feel free to ask your questions. I'd love to answer those. So I wanted to kick it off today by quoting actually the CEO of our company, Amazon.com, Jeff Bezos, who said something which really drives the motivation of doing data analytics. And Amazon.com, as you might know, is a very data-driven company. So we measure a lot of things and we analyze them, and that allows us to improve customer experience. And where's that coming from? Well, basically, he said, we see our customers just like guests that we invite to a party, and we are the hosts, and it's our job as a company to do every day to make that aspect of the customer experience a little bit better. And you're all into data analytics, you work probably a lot with tools like R and so on, and you sometimes might think about, why am I doing this? And it really translates back into giving a great customer experience. How do you do that? Well, generally you want to start with collecting information and data before you get to the data analytics part. Where do you get that data from? Well, very often you already do collect a lot of data that you can start logging, like log files, etc. And from those you can derive an individual customer experience. If you have an online business, like Amazon.com, which is a retail business, you click through shopping carts and so on, that creates requests against the web service, creates a log file, and that eventually allows you to look at individual customer experience, what they did, what they've done, what have they put in their shopping cart, etc., and then improve that experience. And that is truly the motivation of data analytics. Increase or improve the customer experience, and as such, if you run a business, obviously increase your business revenue. Now, how do we get into open source? Where does that specifically fit into data and analytics? And you'll find that when we talk about big data or data analytics, a lot of tools like R are completely open source. There's some commercial versions of it available. But I think one important project that really kicked off the entire big data discussion is this yellow cute little elephant here, which is the logo of the Hadoop project. Hadoop was a framework that was created by two engineers at Yahoo, based on a research paper of Google. So that was an interesting scenario that was created here. But basically what Hadoop does, it's a system to do distributed computation and do that on a distributed storage, and do so on commodity hardware. And that was actually a deal changer to the world of data analytics. Because if we talk big data today, it's nothing new. Like, data mining has been done for the past decades, for many, many years. The only difference that we now have is that we do so on very large data sets. So having a possibility to actually do, standard basic data mining algorithms on large data sets required us to do that with different systems. And Hadoop was the first kind of project that kicked that off and said, you can use any kind of hardware, any kind of server you got lying around, can be commodity because it's a fault-tolerant distributed system. And the reason I'm mentioning Hadoop, because you probably see that today you don't do much pure Hadoop anymore. You very often do something along the lines of the Hadoop ecosystem, but it really kicked off an entire bunch of different projects that build on top of Hadoop and that allow to do some of your, or to accommodate some of the data analytics needs in a distributed manner. I mean, just to look at a few like Spark, Hive, Mahout, Flume, etc. Spark is a very interesting one. Obviously, there's also R on top of Hadoop. And I don't want to go to that list, but I just wanted to showcase on what different projects you can have and how that got really triggered from the Hadoop project. So if we talk about big data, just dissecting that a little bit further, what do we really mean by that? Well, people always say big data is the 3 V's, right? Volume and variety and velocity, so having more data coming in at a faster rate and having different kind of data sets. That is the status quo. And if I look at it from an engineer's perspective, I say, well, big data is still what we've done in the past, but there's one big difference, which is really we need to start to change and innovate on how we collect and store information and how we process it in terms of the sheer size and volume that we have. Because we can't do it on one single machine anymore. Previously, we loaded the CSV file into a laptop and we got insights out of that. So obviously, that changed. And to put that a bit into perspective, I just wanted to show an infographic. This is from gogolf.com. This is about 2 years old. So I reckon these numbers have, probably at least doubled. This is what happens in the internet every 60 seconds, right? And we see things which I find quite interesting. Obviously, lots of Google searches, like over nearly 700,000 Google search queries. An interesting one is 600 new video uploads to YouTube every 60 seconds. Another interesting one is 370,000 calls on Skype, 100 plus new LinkedIn accounts, 1,700 Firefox downloads every 60 seconds, and so on. Now, obviously not going into the individual pieces here, I just wanted to show what kind of data is generated at what kind of velocity every day, right? And if you build something these days, when you say I collect a lot of data, tomorrow it's only going to be more, and the day after even more. So we need to think about ways of doing that a little bit more effectively. If you think about data analytics, you generally have some data generation somewhere, you collect it, you store it somewhere, you then want to perform the juicy part, right? To kind of do your computation, get an insight out of it, and then share that across. Now what you'll find, everybody in here has probably a smartphone in his pocket, a laptop on his lap, a tablet at home. Devices are cheap. Generating data is even cheaper. Everybody hogs on a 3G, 4G network, regardless where you are, and you continuously collect, generate data that we throw into a platform. So with that in mind, we have a very high throughput of data generation that comes cheaply, but the problem here still is there in terms of how do we collect and store that data, and how do we especially compute on that data that just gets bigger and bigger. And that is actually quite constrained. So here we still have the same constraints that we used to have. So how can we work with that, thinking about data just becomes bigger, yet we want to work on it with the same tool. So we need to change that a little bit. And we don't want to keep on racking and stacking servers just to kind of maintain a platform to analyze data. Now this is where cloud providers come in. So Amazon Web Services, for example, can help you to remove some of those constraints. So let me just dissect that a little bit. If we think about big data, we think about potentially massive amounts of data sets. If it's a cloud environment like AWS, you virtually have unlimited capacity in terms of storage. Now there are different storage options. I'm going to go into it a bit in which one we want to use. We also want to, and if you work with R, you probably know that. You try something out, it doesn't work, then you try something else, then you put a model on it. You keep on trying things out. So experimentation is fairly important. If you think about an infrastructure, you also want to have an infrastructure that allows you to experiment. Even if you want to say, I want to simulate something, I want 100 nodes of a Hadoop cluster, for example, to run this R simulation on top of it, I want to have an on-demand infrastructure. And that also translates into, when are we doing data analytics? Potentially not all the time. Sometimes we just do it once a week. right? So sometimes we have this complete, a steady workload, and sometimes it just spikes up because we need to compute something. The cloud environment kind of gives you those capabilities. We feel very comfortable having this highly variable workloads. And the last one is more interesting because it actually defines what tools we're using and what storage we're using, which goes into, is our data structured? Think like a database table, that's structured data. Or is it unstructured? Is it like a data blob, an image, a CSV file, which is a semi-structured data. And a cloud provider like AWS provides you with the tools to store all of those and process them individually. And it depends on what data we're processing, on which service we're going to use. So today's talk is going to be about real-time data processing. However, I always like to refer to it as 3 different types of data analytics. The first one is obvious. The first one is create a report, a retrospective analysis of what happened in the past. Showcase me how my user used my game, how they used my platform, how they shopped on my e-commerce platform, for example, report it back. This has lots of value for me already because I understand my users a little bit better. I potentially identify problems, right? I potentially identify problems with my software, with my customer experience, etc. So lots of value in there. However, given the fact that we're always connected these days and our attention span is always shorter, I know that my mom always keeps on telling me that, like, you're way too nervous, like, you can't wait for something. I mean, yeah, because it doesn't work fast enough, right? And that's kind of the experience. Where 15 years ago, you would be happy to kind of do something, get a report in a week's time. Now I want it really fast, because if I don't get it fast enough, I potentially lose my customer. And I get a few examples of that. And then obviously in the direction also where R is used a lot is the other part, which is to now say, I know what happened in the past, I know what happens now in real time. Now I want to predict what potentially could happen in the future based on my past performance. So that's obviously the tie back. We can only predict if we're already doing this, right? If we don't know what happened in the past, then we can't create a good prediction model. So let's focus today a little bit about the here now, the real-time data processing and dashboarding of it.